Hey, 8.6 is on vectors. If you've taken a physics class before, this will all sound pretty familiar to you. Vectors are how we talk about the movement of objects, their motion. Now, when objects are moving in three-dimensional space, we need to try to represent that on a two-dimensional medium, piece of paper or screen. So some of the things we're going to do may seem like we're dumbing it down, and we kind of are. But we're trying to represent it as accurately as we can, okay? So if things don't seem clear, make sure you ask in class. So buckle up, a lot's going to happen in this video. If you have any questions, write them down. Make sure you let me know, okay? A vector is the way we talk about the motion of objects, okay? A vector is a quantity, a number. It represents both length or magnitude, the amount of speed or oomph behind the object that's making it move. And direction, so where is it going? So where is something going and how quickly is it going there? One of the ways we talk about vectors is in component form. So kind of talking about the horizontal and vertical pieces of the vector, really the horizontal movement or length. We have direction, the direction is horizontal, and the vertical the length. We have the direction, it's vertical. So just need the number for the length, the amount of oomph behind the object that's moving it in that direction. So when you do component form, we have these kind of sharp parentheses, x, comma, y. And the x is the horizontal. Of course, y is the vertical. So component form of vector CD, you see the vector, the little hook over the CD. That is 2, 3. 2 horizontal movements, 3 vertical movements. So you can write component form from a picture or from numerical information. So GH, we have vector GH. Let me see how I'm writing it. Of course, it skips back again, so I just that okay. GH, we're going from H, that is the initial point, to G, the terminal point. So it goes left, and then it goes up. So left, my horizontal will be negative. Up, my vertical will be positive. So negative 3, 3 left, comma 5, 5 up. Vector MN, initial point M, terminal point N, going from negative 8 to 2. And then going from 1 to negative 7. So one way you can do this, you can find the difference between the points. Terminal, difference with initial. So 2 minus negative 8, the x of n minus the x of m, and negative 7 minus 1, the y of n minus the y of m. That gives you 18, that gives you 10. I'm just going to start over. I don't like the bracket, I messed up the 10, the comma looked like garbage. Okay. 10, comma, negative, I almost wrote 18 again, okay? So 10 movements from to the right from negative 8 to 2, 8 movements down from 1 down to negative 7. Now, component form talks about the movement of the vector, how far you're going. The magnitude talks about the amount of movement. The notation looks like absolute value bars, but it's not absolute value. It's a reused notation because I guess we ran out of symbols to use. Now the amount of oomph behind it would be the length of that vector. So 1 left, 5 up. So 1 left, 5 up. We wanted the length of the vector. Boy, that looks a lot like a right triangle. You know, maybe because it is. So the magnitude of vector CD, gonna do some Pythagorean theorem. -1 squared plus 5 squared comes out to 1 plus 25 root 26. So the amount of movement that is propelling the object is root 26 amounts, whatever your unit of measurement is, okay? Go ahead and take a look at that other example. Check your work with my completed notes. You also want to talk about the direction of a vector, where it's going. A direction angle is the angle formed by the vector and the positive x-axis. So direction angle is very, 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 very similar to angles on the unit circle that we looked at earlier in the chapter. So example 3, the force exerted by a tugboat is given by this vector 7, 3. Find the direction of the vector to the nearest degree. So we have a vector 7, 3. So there's a vector. Want to find that angle. 7, 3, and of course this is a right triangle. So pretty simply, we have opposite and adjacent. So tangent of our angle theta would be opposite 3 over adjacent 7. So to find the angle theta, we're going to do inverse tangent of 3 over 7. Plug that into your calculator, round it, you get about 23 degrees. Now when two vectors interact with each other, so there's one object going this way and the other going this way, they collide, and what happens? Let's assume they join forces. What happens at the moment of impact? What is your new resultant vector? This is where you add horizontal and vertical components. So you have vector u, vector v, and you want them to collide, and you get one resultant vector. You're going to add their horizontals and add their verticals, okay? So let's put all this together. Really, the entire chapter. Let's put the entire chapter, everything we learned, into this example. An airplane is flying at a constant speed of 40 miles per hour at a bearing of north 70 degrees east. So north, but then 70 degrees to the east. So 20 degrees north of east. A 60-mile-per-hour wind is blowing due north, so blowing the plane further north. What is the plane's actual speed and direction? Round the speed in the hundredth, direction in the nearest degree. So let's start with a drawing. So all the directions are north and east, so we're in the first quadrant. So we have the wind blowing due north at 60. And the plane is constant speed of 400. And is north 70 degrees east. So watch my highlighter color, okay? North, but then 70 degrees east. So between the positive y-axis and the vector 70 degrees, that means between the vector and the positive x is 20 degrees. So we want to find the component form of the plane. We have the magnitude of the plane, 400, but we want to know what is the horizontal and what is the vertical, x and y. So to find those, do some right triangle trigonometry. So to find x, cosine of 20 degrees will equal x over 400. Multiply the 400 over. So 400 times cosine 20 degrees is x. And x will be, let me plug that in. I'm not a genius, I don't know that off the top of my head. Who does? I'm sure someone does. That's not me. 375. And let's round 3 decimals. 3 decimals, the gold standard. So let's do that. So that's the x horizontal component. 375.877 to the east. Now let's find the vertical component. So sine of 20 degrees equals opposite over hypotenuse. And you may be asking yourself, like, why didn't he ever use tangent? Well, tangent requires opposite and adjacent. And we didn't have either one. So we couldn't really use that. We had the hypotenuse. So we need to use sine and cosine. So y is 136.808. So this plane flying northeast, but the wind is blowing north, so the plane is blowing the wind further north, okay? So now we need to get the resultant vector. So what are the actual components of the plane and where it's actually flying? So resultant vector. That's going to be the plane, which has components. We just found them. 375.877 and 136.808. And then the wind. The wind is due north, so no horizontal components. The vertical is 60. You may hear my cat at the door, clawing, meowing, wants dinner. But dinner's not for 38 minutes, so cat, chill out. So the resultant vector, if you put it all together, is 375.877 196.808. Alright. So the plane actually has those components. Now to find the actual speed and the actual direction. So to find magnitude, got to do a little Pythagorean theorem. So 375.877 squared plus 196.808 squared. Then square root of all that, you get about 424.28 miles per hour. So the wind speeds the plane up about 25 or a little over 24.25 miles per hour. Think if the wind was blowing south, it would slow the plane down. But plane going northwest, a north wind gives the plane a little push. To find the direction angle, now we have the component form of the resultant vector, so we have to do some inverse trigonometry with that. So to find our new theta, the component form is x to y, opposite and adjacent. So 196.808 over 375.877. That's a poor looking sevens right there. So 7 and 7. And you round that to the nearest whole degree, that's about 28 degrees. So the plane did have a 20-degree direction angle. The wind blowing it north pushed that angle further north, up to 28 degrees. So take a look at example 5. Check by complete the notes online. I'm gonna go feed the cat in about 30 minutes. He's diabetic, so he probably needs insulin too, so I should do that. So long.